So now we're going to do inverse trig functions. And the reason we got to go back and do them is that it's actually not quite that straightforward, inverse trig functions and how they work. And it has everything to do with domain and range. And you can't understand the domain and range of inverses if you don't understand the domain and range of the actual functions, sine, cosine, and in this case tangent too, because we use tan minus 1. So that's why we've got to go back and do it a little. I mean, this is one aspect of it that when you get into math analysis, you're probably going to find this just a little bit confusing. So we'll touch on it. You'll do more with it there than you will here, but at least we can say that we saw it. So you got to remember, what does an inverse function do? An inverse function does exactly the opposite of what the function did. Right? If f of 1 equals 2, then f minus 1 of 2 equals 1. Right? They point exactly opposite directions. Right? Now, something like f of x equals x squared. We know how to find an inverse of this, right? Replace the f of x with a y, and then switch the x and the y, solve for y in the new location. You get y equals plus or minus the square root of x. So f minus 1 of x is plus or minus the square root of x. But just because you can go through those steps doesn't mean that that's actually the inverse of y equals x squared or f of x equals x squared. Because we know this characteristic about inverses got to be that they point exactly in reverse directions. Right? And you take, for example, if f of x equals x squared, then what is f of 2? 4, right? Absolutely it's going to be 4. But if I try to take f minus 1 of 4, I don't get 2. I get plus or minus 2. It doesn't necessarily undo the function that I started with. That means it's not really the inverse of f of x equals x squared. So, what it really means is that between these two functions, we know that f of x equals x squared looks like, let me put this up, looks like it's a parabola that opens up. And that means it's a function. Okay, but when I do the inverse, I get a parabola that opens to the right. And it's not a function. That's why when you plug in one x value, you get more than one y value coming back. So it's not enough that you can go through these steps and find the equation that represents this so-called inverse. It has to be that both of those are functions. Right? If they're not both functions, then they're not really inverses of each other. We couldn't use them to solve equations. And that's the whole point of doing these things. Right? On some functions, like our trig functions, we can't solve them algebraically. There's no amount of, adding and subtracting from both sides, which is going to isolate an angle, which is inside a trig function. We need what these called transcendental functions, inverses for those kinds of functions too, not just algebraic. So this same thing comes up with trig functions. Like I can say that the sine of pi over 6 is 1/2. Right? Sine of pi over 6 is 1/2. But if I look at the unit circle, I thought I had that open, but I can open it again. If I had to say, where am I? There. What is the sine inverse of 1/2? That's like saying, where does the sine equal 1/2? And looking on the unit circle, the sine equals 1/2 here. That's true, so that would tell me that the answer is pi over 6. But actually the sine equals 1/2 here, right? At 5 pi over 6 too. So in the same way that when we did the inverse for f of x equals x squared, the inverse is not pointing to just one value. So it wouldn't seem like it has an inverse. And yet, if you look on your calculator, what do you see? There's a sine minus 1 button. So clearly there's an inverse to the sine. So how is there an inverse to the sine? That's the part of this that we got to go into a little bit more detail. Right. This is the graph, one period of the sine. I've drawn it from, looks like it's going from negative pi to positive pi. Just going through one cycle right there. The domain is all real numbers. The range is -1 to 1. Okay, that's what we did in the homework last night. Now, the sine inverse should be a flip just like we flipped that parabola to go to the right, you would take that same sine function and you would flip it across the line y equals x. Now it wouldn't be a wave going along the x-axis, it's a wave going up and down the y-axis. Now, does that blue line there, would that pass a vertical line test? The answer is no, it wouldn't. So the sine function, that the first graph, the first wave, that's a function. It passes a vertical line test, but the inverse is not. So you have to say that the sine inverse, as drawn right here, is not a function. So it shouldn't seem like we've got an inverse. Now again, domain and range just switched between those two. Now, one thing I've never shown you before is you can actually do inverses in the calculator. You can do the graphs. I mean, I haven't found a way to make it like terribly useful. Let me do this. Second plus 712. Right, and now I'm going to check my mode. My mode has got to be in radians. I'm going to set this to go, because I have that graph, negative pi to positive pi. So I'm going to use that. Negative second pi, enter to second pi. And I'll leave it as 1, that's fine. And then I'll go negative pi, negative second pi, enter, to positive pi, and I'll leave it at 1, and I graph the sine x, close, and I look at the graph, and it should be pretty much what I just drawn there. Okay, so now here's the thing you can do, if I can get this right. You go back to the main screen. If you look see above the, I think it's above the program button, it says draw. So second program, draw, and if you go down, it says draw inverse. So then I got to say, okay, draw inverse, and now you got to say, okay, well, which inverse of what? And you've got to get that y1 where you put the sine function. So the way to do that is you go to vars, VARS, yvars, and 1 for function, and then you can pick 1 to say now we're drawing the inverse of y1, and notice on the screen it actually takes the sine and it draws the inverse. So I'm not sure how that would help us for much of anything, but it is something the calculator does. So bottom line, we've learned that if we don't do something about the domain and range here of the sine function, then we don't really have an inverse. So we're going to do something about that. Okay? And that is, instead of taking that entire wave from negative pi to pi, we're just going to take the piece from negative pi over 2 to pi over 2, right, where I've highlighted in blue right there. So the domain now is not, for the sine function, is not all real numbers. It's just negative pi over 2 to pi over 2. The range is still negative 1 to 1. So by limiting the domain, we didn't change the range. That's important. Okay. Now, when I flip that, I've only got that piece of it, and that would pass a vertical line test. Right? So by limiting the domain of the sine function, we're actually limiting the range of the inverse so that it doesn't keep going and giving us more waves up and down that would fail a vertical line test. So the domain now of a sine inverse function then is negative 1 to 1, right? Because the range of the sine was negative 1 to 1. But the range of the sine inverse is negative pi over 2 to pi over 2. So we have to limit the domain of the sine function before we flip it to make a sine inverse. And that's what the calculator is doing when you do an inverse function. And it comes into play, you'll see it in some of these problems here, where you have to understand that the calculator, it is only going to, when you do a sine inverse, it is only going to give you values in between negative pi over 2 and pi over 2, or in between negative 90 degrees and 90 degrees. You know, what if you have something where you know that you're in 90 to to 180 degrees or 90 to 270 degrees, it's not going to tell you that. That's where you have to say, okay, but I know that that's what the calculator does, and then, make some kind of adjustment so that you're using the inverse function correctly. And the same thing goes for cosine and tangent. I mean, you can tell cosine is the same kind of a wave as the sine, so it would have the same issues, right? If you have a wave going up and down, it would fail a vertical line test. I should have put this one up before, but that's okay. If I go back to this is the one we did last class. Look at the tangent function, right? If I include all the branches here, right? I mean, actually, each one of these passes a vertical line test. But if I flip this thing, now I've got all these things going this way. Definitely going to kind of fail a vertical line test. That's why we have to limit the domain of this one too, from negative pi over 2 to pi over 2. So you're just dealing with one of those branches. So between these three, sine, cosine, and tangent, we have to understand that the sine function is only going to, when you do sine inverse, it's only going to give you answers in quadrants 4 and 1. That's in between negative pi over 2 and pi over 2, or negative 90 and 90. The cosine, it's actually between 0 and pi, which is quadrants 1 and 2. Right? And the tangent is in 4 and 1. These two are the same. Right? These two are the same, and the cosine is a little different. So we always have to keep that in mind when using these functions. Now, that doesn't mean that we limited the domain of the sine and the cosine and the tangent. We didn't, okay? We're just saying for the purpose of the inverses, we had to limit it, right? Sine still has a domain of all real numbers. That graph goes on forever. Okay, so cosine inverse of root 3 over 2. Now, if we haven't got to this point yet, I mean, to me, whenever I see like the inverse function, I think to myself, that's like saying, where does cosine equal the square root of 3 over 2? I mean, that's just what I'm saying to myself as I'm doing this, right? Where does the cosine equal root 3 over 2? Okay, well, root 3 over 2, I know that's one of these coordinates from the unit circle, right? So on the unit circle, I'm looking for a root 3 over 2, and I'm looking for it in which position, x or y? Since it's a cosine, it's the x coordinate. So where does the cosine equal root 3 over 2? Right there. It's there. It's also here, right? But remember, the cosine is only done in quadrants 1 and 2. Right? So we don't need this answer, we need this answer. And the answer is pi over 6, or 30 degrees. How about the sine inverse of 2? Again, that's like saying, where does the sine equal 2? Is 2 a unit circle coordinate? No. In fact, if you look at the unit circle, and just this is kind of important, right? You got to say, what's the maximum value of the sine? 1, and the minimum is negative 1. Could the sine ever equal positive 2? Just sine x? It can't. So when you get something like that, you just have to say, does not exist. D and E does not exist. And how about the tan inverse of negative square root of 3? Remember, for tangent, you're only looking in quadrants 1 and 4, right? We're not looking anywhere else. And are we going to see the tangent in any case on this? No. What is the tangent? I mean, given the unit circle, how do I find the tangent? It's y over x, right? And so you can't see it directly, but when you're seeing a square root of 3, I mean, if you don't remember like some of the problems we did in that first unit or that we went over on the test last time, the fact is that we did have answers that turned out to be something like square root of 3 or negative square root of 3. And the way you get that is the way I always look at it is like this. If I can make it negative square root of 3, right? And how about if I go divided by 2, oh, in fact, it's not even I'll take it one more step. If I make a negative square root of 3 over 1 and then divide the numerator and the denominator by 2, right? Now I recognize those coordinates. That's negative square root of 3 over 2 and 1/2. Okay, or it could be, we don't really know where the negative goes. It could be that, or it could be positive square root of 3 over 2 over negative 1/2. And one way or the other, that whole thing ends up being a negative. You know, and we know that it should be the y on the top and the x on the bottom. So now we're going to look, because it's tangent, we're only going to be looking in these two quadrants. Where is it that we get some combination of negative square root of 3 over 2 over 1/2, or, you know, positive square root of 3 over 2 over negative 1/2? Isn't it right here? Right? If I divided negative root 3 over 2 by positive 1/2, I would get negative square root of 3. So the answer is 5 pi over 3, or 300 degrees. So, I mean, you could find another place on the unit circle, which is that is true. That would be right here, right here. But again, we don't look for tan inverses in quadrant 2. We only look in 1 and 4. Okay. So try to figure out if you, where would you evaluate these? Where does sine equal root 2 over 2? Remember, that's got to be in quadrants 1 and 4. Where would tan equal negative 1? That's got to be in Q1, Q4. Where would cosine equal 1/2? That's only looking in quadrants 1 and 2. And where would sine equal negative 1/2? Again, sine is only in quadrants 1 and 4. And where does sine equal root 2 over 2? Pi over 4? Okay. Pi over 4, right? You're only looking in quadrants 1 and 4. So root 2 over 2 is right there, pi over 4. Okay, where does tangent equal negative 1? In order to get a 1 or a negative 1, it must be that they're the same coordinate. The x and y absolute value have got to be the same thing. So where is that true? Where would the tangent equal 1? Meaning, where is x and y the same? How about there? Root 2 over 2, root 2 over 2. Right? If I divided y by x, I get 1. But I don't want 1, I want negative 1. So where's that going to be? That's going to be here, right? You know, it could also be here, except you don't look for tan inverse in that quadrant. You only look in 1 and 4. So that's got to be negative pi over 4. You know, we're not even using 7 pi over 4 because, again, the answers are supposed to be... Go ahead. If you got to go, go. Right. When you do a tan inverse, or you got to give your answers between negative pi over 2 and pi over 2. Okay, where does the cosine equal 1/2? Okay, cosine is 1/2 here. Okay, again, it's 1/2 down here at 5 pi over 32, but we don't look for cosine there, or cosine inverse. So that's got to be pi over 3. And where would the sine equal negative 1/2? Negative 1/2 here. Sine is negative 1/2, so that's negative pi over 6. Right? That would be positive pi over 6. It's negative pi over 6. Oh, did I mess that up? Oh, sorry. Sorry about that. It was, yeah, on the slide it was negative pi over 2. If you were saying negative 1, it would have been negative pi over 2. Right. Sorry about that. Okay. So now we can get into solving equations using inverses, which we kind of already done a little bit. But when you do this with right triangle trigonometry, you're always, your angles are always between 0 and 90 degrees, or 0 to 180. Well, it's got to be between 0 and 90 for a right triangle. So you only have positive values. Okay, here that's not true, right? So we're going to have to say, what's the sine, if sine theta equals -5/8, then how do we solve for the angle when it's inside? You take sine inverse of both sides, right? Because we limited the domain and the range of these things, we can do sine inverse of the sine. We can take the composition of both of these things, right? This will be, you don't have to show this step all the time, but literally what we're doing is we're going sine inverse of the sine of theta equals the sine inverse of -5/8. Okay, and the sine inverse of the sine, because we limited the domain, those are both functions, they cancel each other out. Now you get theta equals. Now, if those numbers, -5/8, were like unit circle things that we're familiar with, like the last slide, then we'd probably expect an answer from the unit circle. Maybe it would say something like, give an exact answer. But we don't. But that's not true here. So how are we going to do this? With the calculator. So, and it says, since it gives the domain, we're only interested between 180 and 270 degrees. We know that sine could be negative in two different places, right? But we're only interested in 180 to 270. Which quadrant is that? Yeah, it's got to be between 180 and 270, means we're only looking for our answers here. We can find the same answers here, clearly, because sine is negative in both of those quadrants, but it said don't look there. Okay, so we're going to go to the calculator, and we're going to do sine inverse of -5/8. And let's put it in degree mode because they're giving us a degree. Mode is degrees. Okay, second quit. Sine inverse, second sine of -5 divided by 8. And it tells us that's -36.68. Let's call it -38.7 degrees. 38.7. -38.7 degrees. Okay, now go back and look at the unit circle. Where is -38.7? The negative tells you to go down, right? So if I start here and I go this direction, 38.7, that's going to be somewhere over here. But it said to give an answer over here. So how do I find the angle straight across from that where sine has the same value, meaning the y-coordinate is the same? Well, again, how many degrees did we go down from 0 to get to this point? It was -38.7 degrees. Okay, so we need to go 38.7 degrees this way, right? So we're going to take 180 and we're going to add 38.7 degrees. What do you got? 218.7, right? So the answer is 218.7 degrees. So I'm going to say this is from the calculator. And the calculator is only going to give you values for sine inverse in between negative 90 and positive 90. But we know that we're actually being told you want the value that's across from it in quadrant 3. So you're going to have to do something to find it. Okay, let's try another one. Or you try. Solve. Sine theta equals 0.62. You want to give your answer in between 90 and 180 degrees. So you can just go right to the step, which is theta equals sine inverse of 0.62. Okay. So sine inverse of 0.62. 38.3. Could that be our answer? Right, that's from the calculator. But remember, we were told we've got to be between 90 and 180. So I'm not even going to use the unit circle. I'm just going to draw myself a circle here. Right? So 38.3 would have been about right there, right? Okay, but we need to be, we know we're supposed to be between 90 and 180, and this is the sine. So we should go straight across this way and figure out then what would this angle be? It's 180 to here, and then this distance, this here, represents 38.3. So what is the value here? 180 minus 38.3. Right? This way you're going backwards. Right? The one before we were adding, but this time we're going backwards. So we need to go 180 minus 38.3. Right? 141.7. I mean, you can check it out. Let's just take the sine of 141.7. Right? Calculator time. What is the sine of 141.7? 0.62. Okay, so it's got that same value in two places. So we've got to use, first we use the calculator, then we use a little bit of geometry to figure out where's that other answer. Solve. Right, cosine of theta equals 0.4. Okay, so that means theta equals cosine inverse of 0.4, which is 66.4 degrees. Okay, but that's 66.4, you know, that would be .4 is here, about right there. Right, 66.4 degrees. But they want the answer between 270 and 360, which is which quadrant? It's quadrant 4, right? They want us to go straight down and figure out what would that angle be. Right? If you went up 66.4 to find that point, then you would go down 66.4 to find that. So what would be the value? How would you figure it? 360 minus 66.4. $293.6. I mean, try it out. Again, with the calculator, take the cosine of 293.6. and it's 0.4. So this is the calculator answer because it only gives answers in quadrants 1 and 2 for cosine, and this is the real answer because that's got to be between 270 and 360. So try to do that one. Cosine equals negative 0.39. All right, find theta in between 180 and 270. Which quadrant is that in? That's 3. So you're trying to find the answer in 3 when you know the cosine is only going to give you answers in 1 and 2, the cosine inverse. So you have to figure out what the geometry, where does it go? Thank you. Okay, let's go. So the cosine inverse of negative 0.39. Second cosine inverse, negative 0.39. 112.96, that's like 113, right? So theta equals 113 degrees. Which if I put that in the unit circle, 113 is past 90, maybe it's over here, right? Maybe about that's 113 degrees. Again, because cosine inverse, it's only going to give you answers in quadrants 1 and 2. That's why you got it there. But we need the answer between 180 and 270. So that's down here. So how am I going to find that same angle? I'm going to have to go straight down there. So how can I figure out the angle in between 180 and 270? Well, if it was 113 degrees around to there, then what if I go 113 degrees around to there? What would be the math of that? Right, that's 360. What's 360 minus 113? And should that be 247? Which is in between 180 and 270. Okay. Okay, and then a tangent. So take the tan inverse of negative 2.1, calculator, negative 64.5 degrees. Okay, so again, draw my circle again. Negative 64.5 would be in this quadrant here, about right there. Negative 64.5 degrees. Okay, but we're supposed to give an answer in between 90 and 180, which is over here. So for tangent, the way that you find the tangent is you just go straight across the circle. Add 180 degrees. I mean, remember that the tangent is negative in both of those quadrants. So what you're looking for is, in quadrant 4, that was a positive x and a negative y, but in quadrant 2, that's a negative x and a positive y, but the distances are still the same. So what's negative 64.5 plus 180? That would be 180 minus 64.5. (115.5 degrees). Again, you could take the tangent of 115.5 degrees and see that it equals negative 2.1. That would be a good check. So try to do that one. Tangent. Looking for a value that's in between 180 and 270. So first you got to do theta's tan inverse of 4.7. And what does that turn out to? Second tan inverse 4.7. 77.98, 78 degrees, right? Rounded. Theta equals 78 degrees. Okay. That is definitely a quadrant 1 kind of answer. 78 degrees is maybe right there. Right. We know we want an answer in this quadrant. So what do? We add 180. And that will give us 258. Okay, so that brings us down to here. It should be just straight across because the x, the distance from the y-axis is the same, the distance from the x-axis is the same. In quadrant 1, x and y were both positive. In quadrant 3, they're both negative, but when you divide, it's positive. Okay, so the answer is 258. Okay, so now we can get back to, this is stuff we actually did this before, right? Because it's just now we're just doing solving right triangles. How do I find theta? The angle theta in a right triangle. Which, in this particular case here, which trig function are we going to use? It's a tangent, right? You're going to have to look at the angle and decide which 2 out of the 3 sides have you been given. In this case, it looks like opposite and adjacent. So we're going to say tan theta equals 10 over 8. So how do you find the theta? Tan inverse. $51.3. Now, do we have to worry about adding 180 or anything like that? No, because it's a right triangle. We expect all the angles to be between 0 and 90, which is one of the quadrants where tangent inverse is going to give us an answer. So, done. Okay, how about you try to do that one and then we're done. All right, Dylan, what'd you get? Did you get it, or you do it, or not? You're sitting on your hands.
24.6.
You didn't do it though, did you?
No, I did. Then I accidentally deleted it.
Okay. So, which function is this?
Sine.
Sine of theta equals 5 over 12. Theta equals sine inverse of 5 over 12. Theta equals 24.6.